I will ask you to calculate population parameter on the test. How do you calculate that? You use your margin of error and sample statistic. And when you have these two pieces of information, how do you calculate that? You use what to subtract what? Sample statistic to subtract the error, and then use your sample statistic again and add that error. Okay, thank you. So let's try one together to be sure you know what you're talking about. Let me see if I have an example. Okay. So if I say that you surveyed 1,200 people and you found 22% walked to school every day. I just made that up, so it's not a very good example, but it will have all the information there. The margin of error is 4%. So I want you to give me a range of value with confidence interval of all people walk to school every day. So this is just a makeup example. If I ask you some other random question, what is the population here? Is the 1,200 people your population? No. That's your sample. Okay. What is the population? Like it just like people, right? So all people would be the population. And the sample would be the 1,200 selected, right? Okay. What is that 22%? That's your sample statistic. Okay. And then what would be the raw data for this one? All the responses from where? That 1,200 people. Good. And then what would be the population parameter? We are going to need to calculate, right? So the population parameter, we will calculate how? You use your sample statistic minus your error, I heard, okay. And then use your sample statistic to add your error. So 22% plus, subtract 4% to 22%, add 4%, what do we have? 18% to 26% would be the population parameter. This is of all the people who walk to school every day, right? So that's how you calculate the population parameter. Are we okay? Questions? Okay, so we're still in 1.1. And some of the questions in 1.1 ask you to do some kind of fill in the blank, right? And then it will ask you to put in the population parameter and the sample statistic. If you are picking population parameter, they should be related to the population, right? So for the example we have in class, it talk about all students. So because it's talking about all students, and the number representing all students would be your population parameter, right? And then because it's all students, it's basing on the population. Is that okay? And then for this one, because they only sample 250 students, so the number related to that would be your sample statistics. And then because it's basing on a sample. Is that okay? All right. So we also want to talk about the difference between inferential statistics and descriptive statistics. So what are the difference between the two? Descriptive statistic and inferential statistic. Descriptive is describing something, right? Inferential, it means you're making inferences, right? So those terminology would be on the test, and we will ask you to match the definition, right? So descriptive would be basing on sample statistic or population parameter. You're basically just describing what's happening. So whatever information you have, you will use it. But the inferential would be more related to population because you're using your sample statistic to make meaning and understand what the population would behave. So some of you seems to have forgotten that. So you may have to work on this a little bit, okay? It's this exam has a lot of definitions, so there's no good way to study. You just have to work on this slowly. So the descriptive statistic a lot of time deal with raw data and then maybe looking at the graph and sample statistic. The inferential statistic would be making estimation to your population parameter because you're making some meaning basing on the sample statistic basically. All right. What is census? Huh? Census is what? So you will collect information from every single individuals from your population. It may not be a U.S. census, but if you want to run a study and you want to ask questions for every single student on campus, that would count as census also. It talks about the 5 steps of the process for statistics. So the basic step is a lot of time you need to set some goals, and then you need to find representative samples. And then you collect raw data and you're somehow summarizing it so you get the sample statistic. And then using the sample statistic, you need to make meaning to the population parameter, and then you draw some kind of conclusion and see if your goals are met. So all the stuff like we have talked about in class, you have to kind of study it a little bit. But the major calculation for 1.1 is calculating the population parameter, which is using the sample statistics, subtract the error, and add the error. Okay? All right, so that's 1.1. Let's move on to 1.2. So 1.2, we talk about sampling techniques. And we specifically work on a few of the major sampling methods, including simple random sampling. So anybody can tell me something about simple random sampling? How does it work?
You put names in a hat and draw it out.
You just put a bunch of names, draw some out. Totally random. If you have a huge list of names, you may assign them with a number and let the computer pick several one of them. That would be simple random sampling. How about systematic sampling? Every fifth person or third person, etc. Right? You can also apply to quality control if you're manufacturing certain electronic. Maybe you test every 100 units or every 1,000 units. That would be systematic. Some of you are playing with your cell phone, put it away. This is exam review, so it's kind of important. And exam 1 actually have the least material compared to exam 2 and 3, so we want you to score as high as possible. It has a lot of definition, but very few calculation. All right, the next one is convenience sampling. How does convenience sampling work? Whatever is available for you. So if I want to study and I just ask every single one of the people in this room, it would be convenient for me. Or I just go to the hallway and like yell at some people like, can you answer some questions? Like whoever willing to answer it. So that would make it like convenient. Okay, the last two would be the one people get really confused about. Definitely would be on the test. One is clusters, one is stratified. So how are they different? Yes.
So in cluster, you have the big group and you divide them. And then you select, is it all of the groups?
Because it's clustered together.
All the people in the groups, that's cool.
How about stratified?
And that one, it's kind of the same thing. You split up the big group into strata, but you only pick some of the groups, not all of the groups.
Okay, so like if you are confused with them, I would suggest you to look at the picture. So cluster, like they all group together, right? So you have a big group. This one actually label them with the number. So they separate them into 6 smaller groups. But once you have the smaller group, what you do is if you pick this group and this group, you have to sample every single individual in those small groups. So they cluster together. Is it okay? And for the stratified, you will have a big group and then you have subgroup. May not be 2, it may be a lot of them. But once you have the subgroup, you will pick a few from each of the subgroups. So not the whole thing. This one is the whole thing. And this one doesn't pick every single one group. This one will pick from every single group, but they only sample from them. So this one is particularly useful if you want to study maybe for the whole USA. And you want to look at big city and smaller city or rural area. So this one will spread it out everywhere and you will sample a few from each group. So that gives you a better sense of what's going on in the country. Okay, so if I say, I'm going to want to study with all the school in Dallas ISD, okay? And then I'm going to pick 10 schools and survey every single teacher in those groups. Then which one is it? Cluster, because I survey every single teacher, right? After I divide them into small groups. Or one of your example from your book is saying they want to look at the gas price, like close to the rental car company, near the airport. So they, I forgot, this one is too complicated, so let's find something easier. So if I separate, say, the student into freshman, sophomore, junior, and senior, so 4 groups, right? And then I pick 100 from each one of them. That would be? Yes, because I don't survey every single one in each group, right? I sample from each subgroup, okay? So that would be the major difference. On the test, I will give you a scenario and you need to match which sampling they are. Question on this? Are we okay? So this one seems to be, people have a lot of problems, so make sure you get it. Okay, the difference between observational and experiment. Anybody? Observational and experiment. Experiment have treatment and control group. That's true. How about observational study? How does that work? You just observe. You ask them question, you write down the answer, you don't change their mind. So I say something like, you ask them if they live on campus or they commute. You simply record the answer, right? You're not trying to change their mind to move to campus or something. Okay, for the experiments we have, time I give you a scenario, and you guys didn't do as well on the quiz on that. So the quiz question was, if you want to run an experiment study, and it's testing if the shingle vaccine is effective, who would be in the treatment group? The participant who received the vaccine, okay. How about the control group? The participant that would be part of it, or the one in the control group would consist of participant what? Some of you just staring at me like I'm trying to help you. I'm asking you questions from the old exam. Like you need to help me, otherwise like you just go study. Like you're not even trying, so I don't know how to help you. Who would be in the control group?
The person who didn't receive the treatment.
Didn't receive the treatment or placebo. They received the placebo. What is placebo? The thing looks like the treatment, but it doesn't have the active ingredient. So if it's like a medicine, it may come as what? So if it's a medicine, a placebo would be a sugar pill. If it's an injection, it would be a saline injection. Very good, you guys know it. Okay, so there is a few type of effects we mentioned on the test. One is called placebo effect. What is placebo effect? Even though they're getting placebo, but the participant thought they're getting a treatment, so somehow they feel better. How about the experimental effect? What is that?
When the experimenter has an influence on their change because they're biased or that they're able to just
Something. Okay, so think about you doing the vaccine. So if the experimenter, the one doing the injection, know this is treatment or not treatment, so maybe the facial expression or the tone of voice may give it away that this is the treatment. So then the participant will think, okay, I'm getting the treatment, so I feel better. So that's the experimenter effect. So how can we avoid the experimenter effect? Or the double-blind study. So what is the difference between single-blind and double-blind? Single-blind is the participant doesn't know if they're getting the treatment or not. Is it okay? Single-blind means just the participant doesn't know. How about double-blind? The experimenter and the participant don't know if they're getting a placebo or treatment. So who knows? The researcher, the one actually recording the data, know, but the people injecting them don't know. Okay? Question on this. Got it? Okay, so let's see what else. So that is, one more. What is meta-analysis?
taking information from past studies that have been done like a lot of times.
Okay, so if you're studying something, but other people has done similar study in the past, so it's no reason for you to start a new study. It costs a lot of money, it takes a lot of time. You can look at the past study and see what the result is and use those results to analyze and come up with your conclusion. Are we okay with meta-analysis? Single blind, double blind. Experimental and observational study. Are we okay with all those? That's 1.3. Okay, let's look at 1.4. I know I didn't do them in order. But 1.4 has a list of 8 different guidelines to see if a statistical study is believable or not. So we want you to have some idea. On the test, I may have a bunch of guidelines and ask you to pick out the 8 that we have talked about. Or I ask you to pick out the one that we didn't talk about. So as long as you have some idea what that 8 guideline is, you should be okay, right? So for example, if I say the coffee manufacturer tell you that they have a study and drinking coffee makes people smarter, what is the problem with that? What guideline is that they have problem with? The coffee manufacturer telling you drink coffee is,
Oh, why?
you need to consider what? The source, okay? And then if I say, let's ask the student if increasing the student fee is a good idea. If I word it like that, all the student is going to say no. But if I say if you increase $10 of the student fee, then we will include all the textbook and you don't have to buy any textbook, what do you think? Yes. Okay. So it's really depending on the wording and then explaining. So what guideline should I look at for this one? Number 6, consider the setting and the wording of the survey, right? So I may have some questions like that I give you a scenario. And because I list the guideline and ask you to pick which 8, right? So you kind of have the guideline in front of you and then you have to match which guideline match that scenario. Is that okay? So you don't have to memorize a lot of stuff, but you do need to have idea what they are, okay? Question on this. Any one of those you have problem with? So look through 1.4 again. Any question about 1.4? Starting in chapter 2, we have some calculations. Okay, 2.1 is about the data type and the level of measurement. So for this, we have 2 types of data, qualitative and quantitative. How are they different? Qualitative are what kind of data? Category. Quantitative? Numbers. So for qualitative, we also separate them a little bit further with the nominal level and the ordinal level. So how are they different? Nominal and ordinal. Nominal means no order. Ordinal order. Okay, so let's think about something. If I just give you some data and you have to categorize them as quantitative and qualitative, okay? So if I say number of students in each class, that would be quantitative with the number, right? If I ask like eye colors of students, that would be qualitative with the category, right? So if I ask eye color again, would that be ordinal or nominal? Nominal, because there's no order, right? I cannot say the brown color go before green, right? So if there's no order, that is NO nominal. And how about if I talk about the size of shirts, like small, medium, large, extra large? So they are category, right? So category would be qualitative. Is it nominal or ordinal? Ordinal, because there's like small, medium, large, extra large, the order, right? Are we okay with that? Okay, the other one is the number type, quantitative. It has continuous and discrete, right? So continue means it can go like 0.5, 0.5, 0.5, so it doesn't have like a set type of interval. The other one is discrete, which have a set interval, like 1, 2, 3. So if I'm talking about number of people, that would be discrete or continuous. Discrete, because I cannot have half of a person, right? If I talk about time, continue, because it's 0.2 second, 0.5 second. If I talk about the tricky one there, shoe sizes, that's discrete because it's like 7 and they jump to 7.5 and they jump to 8. So that doesn't have 7.2 or something. So it has set interval. If they have set interval, that is discrete. Are we okay with those? All right. So they have kind of a chart here. Maybe it will help you like nominal, no order, ordinal order, right? And discrete and continue. I know the interval and ratio is harder. It's mainly say that the interval, the 0 is not meaningful, and the ratio one, the 0 is meaningful, and the ratio is also meaningful. So those are a little bit harder. So if you can categorize them as quantitative, qualitative, discrete, continuous, and ordinal and nominal, I'm pretty good. Are we okay with that? Okay. All right, so that's 2.1. 2.2. We talk about random and systematic error. How are they different? Systematic and random error. How are they different? Yeah, it's totally random and unpredictable, right? So the example we have there is like a baby moving around on the scale, so you cannot really see the exact weight of the baby. It happened totally randomly. But the next one is an empty scale, but it's a 1.2, so all of the measurement that measured by this scale will have 1.2 as the absolute error, right? So they have to subtract that. So that is something you will have to calculate, including the absolute and relative error. So let's do an example to find absolute and relative error. So let's say the true number that we have is 108.7 centimeter. And then the measured one is 110 centimeter. Okay, and we want to find the absolute error, and we want you to find the relative error. So how do I find those? For absolute error, the measure value need to subtract the true value, okay? So your measure value is 110, right? Subtract 108.7 centimeter. So remember, on the test day, you're going to need to bring your calculator. You cannot use the one on your phone, okay? So today is okay, but on the test day you cannot. So what do I have here? 110 minus 108.7. What do we get? 1.3 centimeters. So this is your absolute error. So how about relative error? You put absolute error on top, divided by true value, times 100%. So your absolute error is 1.3, right? Your true value is 1. True value is 108, yeah, 108.7, thank you. And then need to multiply by 100%. So on the test, you have to show me a little bit step, okay? Even though it looks very simple, you still have to show me like at least this part and this part. How to set it up, find the answer. Okay, so 1.3 divided by 108.7 times 100 is what? So most of these they will ask you to 2 decimal places, whatever that is. So 2 decimal places in the final answer. So you get what? Anybody? It's like 1.19595 something, right? So if I round it to 2 decimal places, what should I get? 1.20 in terms of percent. So this is the relative error. Are we okay? Questions? Can we do that? So you will have questions similar to this. Okay, let's look at 2.2. What else is there? Absolute and relative error. Every time when you need to calculate something relative, it comes with percent. The next one they talk about is the accuracy and the precision. So how are the two different? Accurate, precision. Yes, how accurate something is how close it is to the true value. How about precision? Can I hear what?
Details.
A lot of detail. So like it can have a lot of detail. It can be very precise, but totally not accurate. Okay. So something can give you a lot of detail, go to the 0.1, 0.01, but it's like so far away from the true value, then it's not very useful. Okay. So some of the question may give you some information, and then you have to decide if this is accurate and it is precise. And some of your quiz question is like that too. So let's try one. So if I have, say the true measurement is 20.9 centimeter. I cannot write M today, I don't know why. Okay. And then ruler number 1, I don't know, I'm just making this up. Measure it to be 20 3/4 of a centimeter. So by the way, ruler number 1 only measure to the closest quarter. So what does that mean? It means it will start from 0 to 1/4, which is 0.25 like you say, and then 2/4, and then 3/4, and then to the next value 1, right? So it's like 0.25, 0.5, and then 0.75 and 1. So similar to your quarter, right? To $1, right? So that's ruler number 1. So ruler number 2, say the measurement is 21.4 centimeters. So which, by the way, ruler number 2 measure to the closest tenth, which is 0.1, 0.2, 0.3, etc. Right? Are we okay with that? So if that's the case, which one is more accurate? Which one is more precise? So the question is, which one is more accurate? Which one is more precise? And then they ask you to explain. So your quiz has a question like this, and your exam would have a question like that. And that supplemental homework quiz is going to be due today, right? Try to tell you many, many times. So again, accurate means close to the true value, right? Close to true value or measurement. And precision is they give you more details, right? So one give you closer to the true value, one is give you a lot of details. So what do we think? Which one is giving you more detail? You should be able to tell like without any calculation, right? Which one has a lot of details? Number two is more precise because gives more details, right? Okay, 0.1, 0.2 is more detailed than 0.25, 0.5, right? Which one is more accurate? That one you probably need to calculate a little bit, right? So the difference between which one is bigger? The true value is bigger. So what should I use to subtract? So for the ruler number 1, I can use what subtract what? The true value subtract ruler number 1. Okay, so 20.9 subtract 20 point, this is 3/4 mean point what? 75. So calculate that, what do we get? Anybody? 0.15 centimeter. Okay, how about ruler number 2? We're going to use which subtract which? Like that. Can I use the true value because it's bigger? Subtract ruler, oh no, this one, you're right. 21.4 subtract 20.9. Yeah. So after subtracting, what do we get? 0.5 or 0.50, right? Centimeter. So which one is closer? Ruler number 1, right? So ruler number 1 is closer to the true value, which means ruler number 1 is more accurate. Are we okay? So you may have a question with something like that, which you have to explain a little bit. Questions? Got it? Okay. That's pretty much for 2.2. So we still have 2.3. 2.3 have a lot of math. And that's the shortest exam compared to the other two. The other two have more content, so this one have the least content. So try to do the best you can, okay? Alright, so 2.3 is using percentage in statistics. So definitely you need to be able to convert number to percentage and decimal. So let's try some of them. Make sure you can do it. Okay, number 1. I want to change 7% to decimal and also fractions. Okay, and then number 2, I want to change 11/13 to decimal and also percentage. Number 3, I want 0.68, change it to percentage and then fractions. Okay, so you will have to show me a little bit steps, okay? Alright, so the first one, how do I change it to decimal? Or fractions? Percent mean what? Per 100. Okay, so 7 over 100, right? Would be the fractions. Are we okay? So we divide it by 100. And then decimal? 0.07. So you can either say move decimal 2 places to the left. To the left. Or you use 7 divided by 100, right? Either way you should get that. So a little bit steps. Make sure you show me a little bit step how you get it. Number 2. 11 over 13. How do I get a decimal number? Divide it. So we're going to have 11 divided by 13, which give me a long decimal number, right? Like 0.84615. So normally if I don't say anything, give me 2 decimal places. What do we get? 0.85. Are we okay? Got it? Okay, how about percentage? Okay, I need 2 decimal places. So I would go back to my decimal number here, right? And then change it to percent, which with 2 decimal places, we will have 84.62%, right? So that's why I wrote a few more decimal places, right? So move 2 decimal places. Okay, number 3, the decimal, I need to change it to percentage. How? This is 0.68 times 100% would be 68%, or you can just tell me you move 2 decimal places, right? Fractions? This is 68 per 100, right? So if it's something you can reduce, you will have to reduce it. How? Dividing by, both of them can be divided by 2, and then you will get over 50. Final answer? No, you can still divide by another 2, so we will get 17 over 25. Is that right? Final answer? Which means they can be divided by 4, but you can do it 2 steps, that's fine. Questions. So when you convert them, I need to see a little bit steps. You can write it out, or you can write a step out, etc. Question on this. Alright, so what else is on 2.3? Let's see. Some other math. Okay, so let me look at it real quick, sorry. 2.3. So they have absolute change and relative change, and then we also have absolute difference and relative difference. So they are pretty much the same. Let me see. So let's do this. Let's do another example. So if I say the population in 2016 was 8.3 billion people, and then now, which in 2018, it reached 9.2 billion people. Okay, so I want to find the absolute change and relative change. So absolute and relative. How do I find the absolute change? The new minus the reference, okay, so it's going to be 9.2 subtract 8.3, we're going to get 0.9 of what? Billion people. So that's your absolute change. Are we okay? So that would be good enough step for me. How do we find the relative change? Absolute change over the reference. Which one is your reference? 8.3, the original amount, times 100%. Okay, so 0.9 divided by 8.3 times 100%, 2 decimal places. I had 10.84. This is in percentage. So if you get the decimal number, it will be 10.843. After you round it, it's about 10.84% for the relative change. Are we okay? Can we do something like that? You just need to make sure which one go to the top, which one go to the bottom, etc. Okay? Questions? Okay. The other things on 2.3, we did a lot of the question with percentage, right? So let's start with one that is not too complicated. Let me see what was on the test. Okay, so if I have a question, say 8% of 200 people smoke. I don't know, just making it up. And then how many of the 1200 people do not smoke? So they're asking do not, okay? And they give you the percent that they do. All right, so how do we do that? Yes. Percent of the smoker. So 8% of 1200 people, right? When we do of, it means what? Multiplication. So we're going to do 0.08 times 1200 people, which will give me 96. 96 people, those are your smoker. And then they want what? Not smoke. So it's going to be, that's true. You can do 92% of that, or you can subtract. So 1200 subtract 96 is going to be 1104. Okay. 1104 people don't smoke. So is that the same as 0.92 times 1200? 0.92 times 1200. I know you cannot see. 1104. So you can check it. Okay. So that would be one step. It would be quicker. Are we okay? Something like that. So with the question carefully. Okay, so the other thing they talk about is the difference between more than and of. Okay, so if I say we started with 100, sorry, can I change it? 500 people. And then now we have 1,000 people. So can you see this is doubling? 500 to 1,000, right? So I want you to complete these two sentences. One is say, the new population is how many percent more than, think about it first, the original, I'm not even done with the question yet, original population. And the second one say, the new population is how many percent of the original population. One is more than, one is of. What do you think? The new population is how many percent of the original? I mean, sorry, how many percent more than the original? Okay, this is 500, this is 1,000, right? This is doubling. So the new population is how many percent more? If this is 100%, this is 200%. So this is going to be 200% of the original, right? But how many percent more? If this is 100% and this is 200%, then it's how many percent more than the original? 100%. You guys have a hard time with this. So study this, okay? It may not be exactly like that, but it will be similar. Different numbers. So this is 200% of the original, but 100% more. So actually a lot of people have a problem with this. Study this if you have questions. How about if I started with 500 and then it go to 1,500. If this is 100%, that would be what? Okay, 100% is 500. If you add another 100%, you have 1,000. If you add another 100%, you have 1,500. So this is how many percent? What What is happening with you? 100% is 500. You add an, I'm sorry. And then you add another 100%. Add another 500, that's 1,000, right? If you add another 100%, that would be what? 300%, but 1,500 people, right? This is your 300%, right? So this is 300% of the original. And then how many percent more? 200% more. So this is 200% more of the original, right? But 300% of the original, right? Are we kind of okay? I think need some work. This one you need some work, like, because you're not very sure. So I want to show you one more example, so I have to move on. So the very last one I'm showing you, I'm going to say last year, 20.5% of students got an A. This year, the percent was up 32% of whatever that is. So what is the new percentage of students get A? So do I add them together? No. Okay. So it's about 32% of this, right? So how do I find that? Multiply. So if I have 32% of 20.5%, I need to multiply, right? So if I change it to decimal, the first one would be 0.32 times 0.205. Somebody get me that number, please. Which is how many percent? 6.96%. Okay, got it. So that's the increase, right? So what is the total? So this year, we got our 20.5%, adding the 6.56%. So together we have percent students got A, right? So this one is a little bit harder, but you can think of it as like 100% and then 32% more times this, basically. So if I do like 1.32 times this, 0.205, I should get the same number. 0.2706. Questions. So the last two decimal percentage question may be a little bit challenging, so you may have to review it a little bit more. Everybody get a review? Wait, don't go yet. We have 5 minutes. Everybody know exam 1 is? Monday. What do you need to bring again?
Pencil, calculator.
Pencil, calculator, eraser, your notebook. I may check it. And then everybody hopefully have turned in your quiz, right? I send you multiple emails to remind you, but supplemental homework is the last thing you need to do on D2L before exam 1. Some of you stopped doing homework on Math Excel. I don't know why. Don't forget to do homework on Math Excel, okay? And then how do I access that supplemental homework 1? Activity? Quiz. So when you open it, it have like 7 or 8 questions. Some of them are matching. So they are not super difficult, but you need to do it because like they are all exam questions. So I'm going to show you how it look like very quickly. We have 4 minutes, so don't go yet. I'm going to try to get your money worth. every single minute. Okay, so this look like this. I cannot open it as a student. So the first one is just picking the 8 guideline out. You may have a different